video is sum and different properties of segmentation. So what is that? Some of different properties of segmentation is one of the biggest advantage of segmentation is that sum behave nicely addition, subtraction, and constant factor. These are called a linear property of some different properties of segmentation. So this can be break apart or rearrange sums. Suppose you have sequence AI and BI, and the constant is C. In this video, we will explore segmentation, a closest way to write sums, and learn how addition, subtraction, and constant interact summation. So first, what is segmentation? Segmentation, also called summation notation, is a compact way to write a sums of many terms that follows a pattern, and without writing them all out individually. A general form of this is quantity A summation of B, I equals A, F quantity of I. So, the Greek letter of this capital means sum. The index I is a dummy variable, means summation variable. So what? There are three parts of sum and different properties of segmentation. First one is sums property. Second is different properties. And thirdly is constant factor. Constant and multiple factor.
So summation of quantity 2 I equals to 3 where I is equal to 1 to 2. So first we need to separate. So here is the result. As we can see, there is a constant 2. So we need to move to the this side. So here's the result. Next we need to use the formula of 2 quantity n quantity n plus 1 over 2. So we need to transpose the 2 and quantity 3 plus 1 over 2. So next we need to plus this first, and the result is 4. So next, as we can see, there's a same constant. So we need to cancel these two. And as we can see, we can multiply it. So the result is 12. So where did I get this 9? So I get this 9 into this summation of 3 where I equals to 1 to 3. So I multiply it and the result is 9. And next, we need to add the 12 plus 9 and the final answer is 21.
Here, the second example of sum of property, which is the summation of quantity 3k plus 2, where k is equals to 1 to 2. So, step 1. Using the sum of property of segmentation, write out the sum inside the sigma, which is the quantity 3k plus 2. Then step 2, we're going to separate it. We're going to separate the summation of quantity 3k plus 2, where k is equals to 1 to 4, equals summation of 3k, where k equals to 1 to 4, plus summation of 2, where k equal to 1 to 4. Then, we're going to factor in step 3. So, to factor it, we just transpose that 3 transpose it to the right, so which is we have the summation of k where k equals to 1 to 4, and we, as we can see, the 3 is already here, together with this. So, step 4, we evaluate the summation of k where k equals to 1 to 4. So we just, as you can see, our pattern here is 4. So, k is equal to 1. We're going to start in 1 until 4. So we have here 1 plus 2 plus 3 plus 4 is equals to 10. Then, as you can see, we still have 1 here. So we multiply 1 into 4. So we're gonna have 4 times 1 is equals to 4. Then, step 5, we multiply and add. So, we have 30 times 10. This 10 is from here. So, our k is equals to 10. Then, our 1 is equals to 4. So, 3 times 10 is equals to 30. 2 times 4 is equals to 8. So, we're gonna add 30 plus 8 is equals to 38. Then, our final answer is 38. So, summation of quantity 3k plus 2, where k equals to 1 to 2 equals to 38. So, this is our final answer.
So for the next example, we have an equation here, summation of quantity 5k minus k squared, which k is equals to 1 to 3. So the first step we need to do is split using difference rule. From the word split, we need to separate it. And to be separated, and this is the separated. So the first term is summation 5k, which k is equals to 1 to 3, and second separate is summation k squared, which k is equals to 1 to 3. So the second step is which called use constant rule in first term. So the constant rule in our first term works is 3. So the first term is summation k is equals to 1 to 3. And to be know the answer is from this term we have a pattern 1 plus 2 plus 3. We need to do it because our constant rule is 3. So the answer is from 1 plus 2 plus 3 equals 6. So copy the 5 in there. So you need to multiply it. So 5 times 6 equals 30. So the step 3, which is we need to compute. So we need to compute the second term. And the second term is summation k squared, which k equals to 1 to 3. So the pattern here is our first constant rule is 3. So we need to do like this. So but in the step 3, we need to compute, but we need to do a squared. So k squared. So the rk is equals to 1. So we need to do 1 squared, 2 squared, and 3 squared. From the answer of 1 squared is 1, and the answer of 2 squared is 4, and the answer of 3 squared is 9. So 1 plus 4 plus 9 is equals to 14. And the step 4 is we need to total and get the final answer. And our this 30 is answer from the step 2, and this 14 is answer from the step 3. And the final answer is 16, which is 30 minus 14 is equals to 16.
Now we're going to have another example of the different properties of sigma notation. Now, we're going to have this expression, and this expression asks us to find the sum of the sequence 5i minus 2 for I is equals to 1, 2, and to 3. So the first step we're going to do is to separate the summation, to apply the difference property to split the single sum to two sums. So the summation of 5i minus 2 where I is equals to 1 to 3 will be going to x equals the summation of 5i where I is equals to 1, 2, 3 minus the summation of 2 where I is equals to 1, 2, 3. And the second step we're going to do is we're going to calculate the first term. So, the term in this sequence are, so this is our first term, and the term is in this sequence is this 5i. So 1 for number 1, 2, and 3. So 5 times 1 is equals to 5, and 5 times 2 is equals to 10, and 5 times 3 is equals to 15. And after that, we are going to add all the sums that we got. So 5 plus 10 is equals to 15, and 15 plus 15 is equals to 30. So our sum is equals to 30 in the first term. Our sum in the first term is equals to 30. And the third step we're going to do is we're going to calculate the second sum. So since this is the sum of a constant 2, so we're going to repeat 2 3 times. So 2 plus 2 plus 2 is equals to 6. And the last step we're going to do is we're going to find the difference and subtract the second sum from the first sum. So our first sum that we got is 30. So 30 minus 6. Wait. 30 minus 6 is equals to 24. So this is our final answer.
Is a number that does not change when the index like I changes. So we have an example. The summation 3i is equals to 1, close open parenthesis 2i plus 1. So first step 1. Sigma notation here means I add all values when I is equals to 1, 2, and 3. So step 1, we will plug in numbers one by one. So to change the I into 1 plus 1. We will continue distributing. So 2, change the I into 2 plus 1 plus 2, 3 plus 1. So now we will solve each sum. So 2 times 1 is equals to 2 plus 1, and 2 times 2 is equals to 4 plus 1, and 2 times 3 is equals to 6 plus 1. So now let's add. 2 plus 1 is equals to 3, 4 plus 1 is equals to 5, and 6 plus 1 is equals to 7. So 3 plus 5 plus 7 is equals to 15. So our final answer is 15.